What's up, you scholars of enlightenment? We are back. Haven't done a live stream in a little bit of time, but we've got one today because the OSIRIS-REx spacecraft is returning to Earth with samples from the asteroid Bennu. Now, we are going to watch the return live on the NASA live stream. But before we do that, just a quick introduction to what we are going to be seeing. So, OSIRIS-REx is a journey back into our origins. So what is OSIRIS-REx doing? So OSIRIS-REx essentially fist bumped the asteroid Bennu. And why did it do this? You might have seen the famous images. I think we might have them on the do we have them? Yes. You might have seen the famous images of OSIRIS-REx bumping in, if this loads from the BBC website, bumping in to the asteroid Bennu and collecting about 9 ounces of regolith from the surface of this asteroid. Now, why did OSIRIS-REx want to do this? Well, the asteroid belt essentially has rocks which are the same as they were from the formation of the solar system. So if we can grab rocks from the very, very early solar system, from the asteroid belt, hopefully we can start to understand more about the composition of the solar system and also how the solar system came to be. So it grabbed these 9 ounces of regolith several months ago, maybe a year ago, I think, and it's been heading back towards the Earth ever since. And now it's going to drop off that precious cargo of 9 ounces of asteroid regolith. And these samples are going to be poured over by scientists this year into the future, and a lot of it is going to be held for future generations and hopefully more advanced, higher technologically advanced analysis techniques. So this is the largest return of asteroid material that's ever occurred. A lot more than the Hayabusa mission by the Japanese in 2010. So very, very exciting. Hopefully we're going to find out more about our solar system, more about its formation, and we're going to watch this and see. So very quick introduction. If you have any questions, feel free to put them in the live stream chat, and we will go through them. So let's bring up this NASA live stream and see where we are at with this, because the landing is not long now. So here we are. They are now live. So I will hand over to them and speak when appropriate.
Which soften up that now the SRC land perfectly smooth on that surface. The temperatures are going to be around the 50s, 50 degree Fahrenheit. Low winds out there, calm winds at the surface around 6 miles an hour.
So the landing's going to be in Utah. Anyone who's watching from America, if you can tell me what Utah is like, I imagine it's warm and dry and clear skies to help dump these samples down to Earth.
The helicopters take off from here to head out to Wig just at the edge of the landing ellipse. Our high altitude plane is up in the sky, ready to take images in the infrared of our SRC, and we are here ready to go to cover all of today's mission events. I'm going to be right here with you all throughout the process as we get closer to that entry, descent, and landing. But for now, back to you, Lauren and Jim.
All right, thanks, James. We'll be back to you for mission status updates throughout the morning. For now, let's give you a quick geography lesson on where we are today. We are sitting about 85 miles southwest of Salt Lake City in the heart of the Dugway Proving Ground, a historic Army facility. In less than an hour, the sample will touch down in our landing ellipse at the Utah Test and Training Range, managed by the Air Force, about 13 miles north of where we're speaking right now. Mission teams have set up a clean room just 1 mile away from us, where the sample will end its journey today. Tomorrow morning, a C-17 aircraft will take off
very
from the
important
runway
to get these
behind us
samples
and
as soon
deliver
as we
the sample
can.
to NASA's
Get them
Kennedy
into a
Space
clean
Center
room.
in
We don't want
Houston.
any sort of contamination, any sort of reaction between those samples and Earth rocks, Earth conditions. Straight into a clean room.
Bringing you into the heart of the action. For all of NASA's many missions over the years, OSIRIS-REx lives in an extremely rare category. It not only ventured out into space with cameras and sensors, but it's bringing a physical sample of the ancient solar system back to Earth for detailed analysis. Mission planners selected a small asteroid called Bennu as their destination. Following a successful touch-and-go procedure to grab a sample on October 20th, 2020, OSIRIS-REx has been making its way back to Earth. It's been a thrilling ride, already packed with technical achievements and scientific discoveries. Today's historic landing continues that saga, promising exciting research ahead. Beside our main event this morning, we've got...
So some of you might remember some of those technical problems. So when asteroid Bennu was fist bumped, Brian May, by the way, involved. When the asteroid Bennu was fist bumped, they actually collected more regolith than they expected. And a little bit of the regolith jammed open the sample collection door, which meant that some of the regolith was escaping into space. So they actually had to stop some of the maneuvers, get those samples stowed away when they were in orbit of Bennu to make sure they didn't lose all of this stuff. So they did so much better than they expected that they were losing sample back into space. So eventually they managed to get that stowed and get that sent away. My favorite thing about this spacecraft is how they measure. I'm just going to turn this down a second. We're going to come back to it shortly. Is how they measure the mass of the sample. So how do they know that there's 9 ounces of regolith in this spaceship that's on the way back to Earth? Well, there's a couple of ways. One is that there's a camera that shows that there's regolith inside, but that's a qualitative measurement. It doesn't tell us how much regolith is in there. How do you know that there's 9 ounces of space rock inside a spacecraft when you can't weigh things in space? There's no gravity. So how do you weigh that 9 ounces? Well, it's very, very intriguing. What they actually did was they extend the arm of the spacecraft when it's empty with no rock inside, and they attempt to spin the spacecraft with a small booster. Then they capture rock, the arm is full of rock, and they attempt to do the same. And they look at the angular acceleration of the spacecraft before and after the arm is filled with rock. It's slightly slower with the arm full of rock. So think about trying to spin round, a hammer, a metal ball on a string, rather than a tennis ball on the string. It's much harder with the hammer on the string, and that's similar to having an arm full of rock. So it spins or accelerates in its spin much slower when it's full of rock. And that difference in acceleration of the spin before and after collecting rock gives us an idea of how much rock OSIRIS-REx has collected and is carrying back to Earth. And we think it's 9 ounces plus or minus, a few grams. So a huge collection of rock for analysis later. Let's go back and see where we're at here.
So, Jim, I think importantly, the team can't just open up the capsule right on the desert floor, right? What happens next?
So next we have to safe it, we have to bag it.
So you can't just open it on the desert floor because it's going to start reacting with Earth's atmosphere, with things in the air. We want to know what happened in the early solar system. We don't want it all commingled with things from the Earth. Straight into the clean room.
Special sample container inside, so it does not introduce any contamination from Earth, because we want asteroid, not Earth.
That's right. And I love
go all the way to the asteroid, bring it back, contaminate it straight away. No good.
And so with about a little bit more than 30 minutes to go before the SRC hits the top of the atmosphere, we're going to take a few minutes to dive into the nuts and bolts of the mission itself. We've got a great mission overview to help explain. Take a look.
Hey guys in the chat, if you have any questions or you want to discuss anything, just throw them out. Hi AB, hi Geo, how's it going? Good afternoon to you.
After arriving in 2018,
Yes,
OSIRIS-REx
Coates, you will remember when we streamed the tap 3 years ago, so nice to follow through.
On October 20th, 2020, the spacecraft ventured to a small crater in the asteroid's northern hemisphere. It dodged jagged rocks and towering boulders and plunged its arm into the loose surface, excavating 6 tons of debris while collecting about 250 grams of material. OSIRIS-REx stowed its bounty and closed its sample return capsule. It bid farewell to Bennu in May 2021, embarking on a 1.2 billion-mile cruise back to Earth. Now, 2 years and 4 months after leaving Bennu, OSIRIS-REx is closing in on the
so I said several months. Obviously, I'm losing track of time in my old age, but this was more than 2 years ago. So
will approach to nearly 60
it's been a long journey.
miles from Earth. It will power up and release its sample return capsule at 4:42 a.m. Mountain Time. The capsule must be jettisoned within a narrow time frame and at just the right angle to hit its target, an area of roughly 250 square miles in Utah's West Desert. Once the capsule
Anyone watching, tell me what Utah is like in the comments. I assume it's warm and dry, clear skies.
At 8:42 a.m., the capsule will streak into the atmosphere at a blistering 27,000 miles per hour.
The only reference I have is, I think, the start of Jurassic Park, where they're digging things up, which seems like a very dry place.
As it pushes deeper into the atmosphere, the capsule will rapidly decelerate, subjecting the Bennu samples to a punishing 32 Gs. About 2 minutes after entry, it will slow to Mach 1.4 and deploy its drogue parachute, stabilizing its descent. The capsule will enter special use airspace at 8:46 a.m., almost 10 miles above the Department of Defense Utah Test and Training Range. Radar stations will lock on and track it to within 30 feet of its landing site. At 8:50 a.m., the capsule will extract and deploy its main parachute 1 mile above the ground. It will make its final descent at a leisurely 11 miles per hour, like a marathon runner savoring a victory lap, before touching down in the desert soil at 8:55.
Very nice summary of what we're going to see.
Wow, I get chills every time I see that.
Me too.
Amazing. All right, so we know you have questions, so please continue to send them to us using the hashtag AskNASA. But before we go any further, I've got a question for you, Jim. Why is the mission called OSIRIS-REx? It sounds like a new hybrid kind of dinosaur or something.
It does, but it's actually the name of an Egyptian deity, a bird.
Sounds very Stargate.
It means all the stuff the mission's going to be doing. So we're going to be searching for clues to the origins of our solar system chemically, looking at how we can ground truth all the data we have for asteroids from Earth, other spacecraft right up close with samples. We're going to look at the resource potential of asteroids, metals, hydrated water as in hydrated minerals, and also consider security of our planet from these kinds of objects. It's a big name with a big mission with many things it has to do. It's multiple missions in one.
Yeah, 3 missions in one, in fact. We know we have a global audience for this event, and throughout the morning...
It's a very interesting point, because a lot of you might remember we also live streamed the DART mission, which was to redirect an asteroid. So if we're getting more information about the composition, the surface features of these objects, it's also useful for those kind of redirection tests.
The early solar system, with those bits and fragments we can never get here, so we go and bring them home to connect our solar system. So that's one of the big takeaways of this. We will read the clues of Mother Nature on how our world works in the context of all the rest of the planetary system.
Fantastic. All right, let's take another question. What do we have? All right, from @ndanger817. Approximately how large is the sample size, and what kind of analysis will be performed?
So it's about 8 or 9 ounces. It's about a size of a baseball and a half, and the kind of analyses are amazing. There are toolkits and instruments that can look at nanoscale characteristics that you wouldn't imagine. We could see the hairs on a foot of an ant, but we'll look at those in the context of another object in the solar system. So, wow.
Wow, indeed. All right, we'll be taking some more questions throughout the morning. Okay, so let us head back to the ellipse.
So like I said, this is a huge amount of material in terms of doing analyses on this, right? This is much more material than was picked up by the Hayabusa Japanese mission in, I believe, around 2010. And a lot of this is going to be kept for future generations and hopefully more, higher technologically advanced analysis techniques. So a baseball and a half, 9 ounces, is a hell of a lot of material. This is a huge macroscopic amount compared to the tiny amounts that can be analysed spectroscopically. So we think about Avi Loeb's cosmic spherules, right, which are a few micrograms. You can get a hell of a lot of information out of very small samples because we only need a few atoms to do analysis. So having a baseball and a half is a hell of a lot of material from this meteorite, even though it might not sound like too much in everyday units.
Whether it be munition hazards, of course, and or the industrial hazards, and even the environmentally sensitive areas that we have out here. So.
All right, and how did you prepare for this today?
So preparation has been in the process for a long time. Between myself and Jasmine Nakayama, we've got 40 years worth of explosive knowledge. Most of it is on this range here, so we know the ranges very well. The team and the UTR have been working together, both Lockheed and NASA, and we've been doing rehearsals so that we are more familiar with their capture. And
Thank
thank
you, AB, for doing the conversion there for me. I could have brought it up. So about 255 grams, so about a quarter of a kilo.
Have to ensure that our teams are safe.
Yes, sorry, I was in UK Imperial units mode. So yeah, I tried to Americanize it with baseballs, right? But 250 grams.
We have again done many of the preparations with them already. They've taken safety briefings. They've been briefed on the actual items that we've dropped out here in their range safety brief. One of the hazards that we're going to be dealing with, though, is the helicopters that you see behind us, and they've been through practices getting on and off the helicopters and working in and around them. But I think the biggest hazard that we're going to have is slipping. We had some recent rain, so that I think is going to be our biggest hazard, but it could be fun too. So.
Well, wonderful. I know that you have your last preparations for the day, so I'm going to let you go, and thank you very much for joining us.
Thank you, Sophia.
Thanks, Sophia. Stu's got a big day today.
Oh, my goodness.
A lot to do. All right, Jim, we know we have space fans from all walks of life all over the world.
I always
One
find the
super fan in particular
over-the-top
is a
excitement
well-known
a bit
astrophysicist
weird.
with an
Obviously, it's a really
atypical
exciting. I'm really excited
but I'm
about it, but
guessing you know
the kind of
probably more about
having
Bill
to keep
Gordon
up the
probably
massive
his
smiles
side
for
thing
an hour
and his
is
science thing.
hard
Oh,
work.
that's right. He's literally space royalty and rock royalty. Perfect for a mission to bring back rocks.
Just a true rock star. Let's let him speak for himself.
Hello NASA folks, space fans, asteroid aficionados. This is Brian May of Queen, as you know probably, but also immensely proud to be a team member of OSIRIS-REx. I can't be with you today, I wish I could. I'm rehearsing for a Queen tour, but my heart's there with you as this precious sample is recovered. Happy sample return day, and congratulations to all who worked so incredibly hard on this mission. Especially my dear friend Dante, with whom we already created this beautiful book. God bless you all.
Speaking of rock stars, joining us is NASA's
Amazing.
Lori Glaze, Planetary Science Mission Director. Welcome, Lori.
Hey, good morning.
Great to have you here, Laurie.
Great
to
to
see
have
you,
you.
Jim.
And you and Jim go back quite a ways, right?
Oh, yes. Jim and I actually go back several decades, but we've been working together closely for many, many years, and it's so good to see you here. What an exciting moment.
Laurie.
Thank you.
It is a really exciting day. So OSIRIS-REx is part of a larger autumn for asteroid autumn, as we've been saying. Can you talk about some of the other missions that are happening this fall?
Happy to do that. It is really exciting. We have lots of asteroid missions, and actually 4 of them have major milestones coming up this autumn. Right on the heels of the sample return happening today, in 2 days, on September 26th, is the 1-year anniversary of a little mission you may have heard of last year called the Double Asteroid Redirection Test, demonstrated for the first time humanity's ability to deflect the path of an asteroid. How cool is that? And then coming up on October 5th is the launch of a mission called Psyche, going to visit a special asteroid called Psyche also, which is one of only about 9 of asteroids that we think are made primarily of metal, have a very high metal content, iron and nickel. And then about a month after that, on November 1st, is going to be the first asteroid flyby of our mission called Lucy, which will ultimately visit Trojan asteroids that lead and trail Jupiter in its orbit around the sun. But in November, we'll fly by a main belt asteroid called Dinkinesh.
Wow, check that out.
It literally is an asteroid.
Lots of stuff going on in asteroids.
OSIRIS-REx, is
Really amazing that we can fly all of that way, grab samples and bring them back now to Earth.
Way out there.
Absolutely phenomenal
Actually,
technological
OSIRIS-REx
achievement.
gave us some really important new information about an effect, a force that occurs on asteroids called the Yarkovsky effect. And what that really is we know there's gravitational pulls on the asteroids, and we can predict that with our trajectories, but Yarkovsky effect says that the sun's radiation heats up one side of the asteroid, and then as the asteroid rotates, the radiation radiates off into the deep space. And that actually kind of acts as a force that kind of pushes back against the forward trajectory. And so it changes our predictions on where the asteroid might be. Over time, it really makes a difference. And OSIRIS-REx gave us some fantastic new measurements on that effect.
Unbelievable.
Wow, that is truly unbelievable. Nobody appreciates the Planetary Defense Axe more than me, Jim.
Very interesting. So they're talking about the fact that light essentially has momentum. So if something's absorbing light, it's going to create a force on it. This is the idea essentially behind a solar sail, where light can hit the sail, bounce off, and that change in momentum can force a solar sail forward. Basically similar effect on an asteroid. It's absorbing some of that momentum that can push it. And then when it re-radiates that momentum away, it can push it in a different direction. And these changes and these radiative effects can really change the trajectory of an asteroid over a long period of time. Very, very interesting.
This is not the first time that anyone has captured a piece of an asteroid. On the arrival of the historic OSIRIS-REx sample, we celebrate that the Japanese Space Agency, or JAXA, has already visited 2 asteroids, Itokawa in 2005 and the asteroid Ryugu in 2019. The missions Hayabusa and Hayabusa 2 proved that it could be done and paved the way for today's ambitious goals of this daring enterprise. All right, let's send it back over to
we shouldn't
James
forget
for
that the Japanese have done this before.
Yeah,
That
thanks,
should
Lauren.
be
So everything
that should
continues
be
to phenomenal.
appreciated.
I've been tracking the mission status here. Everyone looks dialed in, ready to go. You saw a few moments ago Sophia with Stu Wiley, our on-scene commander. He's ready to go. He understands the mission. They are ready to get out and recover that sample today. And as I mentioned earlier, just a few moments ago, actually I guess a couple hours ago at this point now, the SRC was released from the main OSIRIS-REx spacecraft. When that release took place, it was given an initial spin, which kind of preserves its angular momentum, its speed as it's coming in to Earth's atmosphere. It's similar to throwing a perfect spiral on a football, and teams are hoping for that perfect touchdown today. What you're about to see is basically the equivalent of throwing a touchdown pass over 10 football fields away and landing it perfectly in that end zone. So you can see on your screen now the mission operations team. They are just next door, dialed in, ready to go. They've been monitoring the vitals of the SRC all morning.
So that's the analogy they're giving for how tight the corridor is for getting this back to Earth, that it's like throwing a touchdown pass over 10 football fields and hitting your guy in the end zone. So gives you a kind of idea of how difficult this is, how technically challenging it is to get this stuff back to Earth without it burning up or skipping off the top of the atmosphere. Have to be very accurate.
Apex visiting that near-Earth asteroid Apophis. A lot coming up in just a few moments. We're going to hit that key milestone of entry, descent, and landing. 13 minutes of punishing descent through Earth's atmosphere to us here in the Utah Test and Training Range. A lot coming up in just a few moments, but for now, back to you, Lauren and Jim.
So just before we get to that, they mentioned again that after dropping off these samples, OSIRIS-REx is going to be heading off to Apophis. So you might have heard of that asteroid a few times. It's always turning up in like tabloid press. Apophis is going to turn up. It's going to smash into Earth. It's going to destroy everything. It's always put as the kind of boogeyman of asteroids. So it's going to head off to Apophis and do some more analysis. So this is not the end of the OSIRIS-REx mission. It is swinging by Earth to fire off a sample capsule and then go off and do more analysis on the Apophis asteroid.
Artemis will explore areas nearly 1 billion years older than those Apollo. Lunar samples from Artemis 3 and future missions will help scientists interpret the impact history of the Moon and Earth, as well as increase our understanding of planetary processes. OSIRIS-REx, the first U.S. mission to collect a sample from an asteroid, will return samples from asteroid Bennu. The rocks and dust collected will offer generations of scientists a window into a time when the sun and planets were forming over 4.5 billion years ago. Samples from OSIRIS-REx and Artemis could rewrite our understanding of the evolution of the solar system. And that's a look at your Artemis Moon Minute. Boy, Jim, how can you not get excited about that?
Oh my gosh.
Oh boy, that's going to be so cool. All right, Sophia is standing at the forward edge of the recovery zone with an update. Take it away, Sophia.
All right, thank you, Lauren. We are under 20 minutes away from EDL. That is entry, descent, and landing. And I don't think there's anyone here on planet Earth who has anticipated this day.
So less than half an hour until the sample is on the ground. Fingers crossed.
Dante Loretta, thank you for giving us time here today.
My pleasure. It's great to be here.
All right, so you are here on Wig Mountain because you are on the recovery team.
That's right.
Can you walk us through what you're going to be doing today?
So I'm part of the environmental sampling group. From day one, this mission has paid attention to keeping that sample pristine. And we're going to come down. We had some rain on Thursday. Most likely we're going to be encountering mud out there.
I have been very interested in this because obviously the sample has to come back through the atmosphere. Very strong gravity, very strong heat. I'm guessing there's no air in the capsule, but is there going to be any chance for it to react with any part of the spacecraft? Obviously you don't want that to happen. I'm sure that's been carefully considered, but you want to stop any sort of reactions, any sort of change to that sample, and get it straight into a clean room.
Yeah, thank you. I'm a professor at the University of Arizona in the Lunar and Planetary Laboratory, and our history goes all the way back to the Apollo missions. The founder of our lab, Gerard Kuiper, mapped the moon, helped pick the Apollo landing sites and the Surveyor landing sites, and we have been involved in every major NASA planetary mission since then. And really the best part of having a university lead a program like this is that it's a great training ground for the next generation. I've been on this program almost 20 years, and I've watched multiple generations of students grow up, become professionals, either join the team. We always take our team members on board when we need to fill roles, or off into other careers in aerospace engineering, science, and many other disciplines.
It's really great to foster those incredible questions about our universe.
Absolutely.
And I know that you need to get back to your team to go on that recovery process.
Big moment's almost here.
Yeah, so thank you so much for joining us, and best of luck out there today.
Thank you.
All right, back to you, Lauren.
Great, thanks, Sophia. Wow, I can't wait for Dante to get his moment in the sun.
Goes Dante.
That is amazing. All right, so Jim, the whole OSIRIS-REx spacecraft
Kind of
is
endearing
not
how excited
coming back today,
how excited
right?
this
It's
guy
just
is.
a part of it.
That's right. This is the whole spacecraft, 40 feet long, the size of a school bus. But this special little thing here, the sample return capsule, is bringing home the goodies. And that's what we've just released, and it will be entering the atmosphere, and you'll be hearing all about it. And the samples were collected at the asteroid back in October 2020 from this TAGSAM thing that inserted them in the capsule, and the capsule was released. So that's what comes home. The rest of this goes on to Apophis.
That's right. We just heard Lori talk about that. But let's move over and take a look at this this replica SRC capsule. Now, this was an engineering model that was used in tests a few weeks ago for a drop test. Can you talk a little bit about the engineering of this?
That's right. This is a very special spacecraft, just like a small version of what we use to bring crews back when they come back home to Earth from the space station. It has a heat shield. It's about 30 inches across, so it's pretty big. It weighs over 100 pounds. Has a back shell, and inside it has the goodies: the sample return canister and the sample cap, the small sample canister. So this is the vehicle that brings those samples protected from all those changes in environment from the top of the atmosphere, 13 minutes of descent to the touchdown point that we're waiting for today. This is a very special spacecraft.
It absolutely is, and it also was used in a drop test, as I mentioned. Let's take a look at some of that footage now.
Right. So just a couple weeks ago, we dropped this replica, this engineering test unit, from 5,000 feet with a parachute deployment, and went through all the operation, the choreography we need to actually make sure we can do it today. And that's what's going to be coming up. And it worked wonderfully. We inflated the big 24-foot parachute. It floated down to the surface at 11 miles an hour. We went through all the recovery operations, the safing, the bagging, and the containment to come over to the clean room here, where we'll be doing that today to make sure those samples are from
They've
Bennu,
been training for this
so we can
day
study
for a
them here on
while.
Earth and not
I think
contaminated by
some
our
dry
wonderful
runs here.
That's right, and you know it's the actual SRC that they use because it is covered in dirt, as you can see
Right.
on here.
This is dirt, scratch marks.
All the scratch marks, yeah.
It's a rough ride,
the
but,
real deal.
but we need it to come home. This
Absolutely.
is a real sort of homecoming.
Right. So there's a lot of science in missions like this. Not only is the SRC a treasure chest with material from the ancient solar system, but the mission itself is a platform for vital research about a range of things that you might not have expected.
Yeah, it's a big old thing. Yeah, it's the little arm that we had is only a little extension on there. I think it's about, they said, about the size of a school bus. And the little arm on the end.
This gives engineers and scientists unique insight into our most challenging questions about hypersonic fluid dynamics by providing data critical to flight safety systems. The scientifically calibrated in-flight imagery team uses ground-based sensors and instruments flying on various aircraft to image asteroid sample returns, launch abort systems, parachute tests, rocket launches, and capsule returns, including Artemis 1 on both launch and reentry. The data we capture provides engineers with information on vehicle performance relative to what computational tools and wind tunnel tests predict. It takes extensive planning to get it right. Upon its return from the asteroid belt, the OSIRIS-REx capsule will be traveling at 12 kilometers per second, or about 27,000 miles per hour. That's nearly twice as fast as objects coming back from low Earth orbit, and it will be among the 4 fastest human-made objects ever to fly in Earth's atmosphere. In partnership with the Japan Aerospace Exploration Agency, Rocket Technologies International...
So this thing is going to be subjected to some very, very serious heat, very, very serious acceleration. So protecting that sample inside, very, very important, and a difficult engineering challenge, which they obviously feel like they've probably overcome.
Joining us now is NASA's Kate Calvin, Chief Scientist and Climate Advisor. Kate, thank you so much for being here.
Thanks for coming.
Thank you for having me.
It is wonderful to have you. All right, so as NASA's Chief Scientist, you're looking at the big picture. How much teamwork across the agency has made to, a day like today a possibility?
A mission like this takes a big team, both within NASA and without. So outside of NASA. So the mission is managed by Goddard Space Flight Center in Maryland. The sample is going to be going to Johnson Space Center in Texas after it leaves here. Marshall Space Flight Center in Alabama does the overall program management. Outside of NASA, we have collaborations both in industry, academia, and international. So Lockheed Martin is doing built the spacecraft and doing flight ops. Kinetics is doing navigation. We have a science team led by the University of Arizona. And then we have
recovery operations. Helicopter 1 has departed wing to station keep outside the landing ellipse.
We got a confirmation that helicopters 1 and 2 have just taken off. Very exciting. All right.
So, Kate, one other thing. As an earth science and expert on how our planet works in climate, can you tell us how this asteroid mission, the samples we return, might impact how we understand life on Earth, how it evolved, and how climate issues now might be involved?
Yeah, so this asteroid Bennu may record some of the earliest history of our solar system. So scientists are looking at it to help us understand planet formation and the origins of water and carbon, which led to life here on Earth.
That's incredible.
That is incredible. And, Kate, I know you've been to several launches. That's our typical bread and butter here at NASA. But this is more of a homecoming. How does that feel?
So that's interesting, because obviously, because we're talking about how the solar system might have formed, if some of the minerals required for life are on these asteroids as well, it's very interesting to see the abundances of those and how those minerals might have gotten to Earth, because there's a lot of speculation about that.
Thank you so much for joining us.
Thank you.
Thanks, Kate, for all you do.
Thank you so much. This seems like a perfect time to dig into some more information about Bennu. Bennu isn't part of the main asteroid belt. It's a NEO, a near-Earth asteroid with an orbit that occasionally brings it in close proximity with us here on Earth. Bennu is about 500 meters in diameter, which is taller than the Empire State Building. It rotates upside down on its axis compared to Earth, with a tilt of over 177 degrees. Scientists chose to study Bennu because
recovery operations. Helicopter 2 has departed wing to station keep outside the landing ellipse.
All right, so you just heard that they have departed WIG. Excellent progress. Fantastic. Woo. All right. Moving on, it isn't as smooth a surface as we initially thought. It's actually covered in pebbles and marked by these large rocks and boulders nearly everywhere. One boulder in particular that OSIRIS-REx had to navigate around was nicknamed Mount Doom and was the size of a 2-story building. Bennu holds the Guinness World Record of the smallest object to be orbited by a spacecraft. How fun. Now let's get an update from Sophia, who is standing on the edge of the ellipse. Take it away, Sophia.
So you missed a little bit of that, but obviously when you want to pick an asteroid to go to, you have to be quite selective. So they picked one that was closer to Earth, obviously easier to go to, that they thought had a particular composition. Turned out to be a little bit different when they got there. And then it was very difficult. Once they got there, they had to do some surveying to see where they were going to put down and punch into the surface. Because obviously if you've got a school bus, you need to be able to navigate that thing down and have the arm be able to punch into the surface. If you're going to hit a load of boulders around and the arm won't be able to reach the surface, then that's a big problem. So there was a lot of surveying beforehand, before a position was chosen to go down and punch the arm into the surface. And that's a little bit of what we heard about there.
System material. It's a really big day for science, and we're just in the beginning phases of today, but we are certainly excited to hear about what will happen and see those parachutes finally descend through our atmosphere. So yes, we're certainly excited, but this is just one phase of this amazing mission. I'm going to send it back to you, Lauren.
See the operational milestones we're expecting throughout the morning. SRC separation already happened, and the capsule is now heading for its rendezvous with Earth's atmosphere. Jim, it always appears like these operations are simply inevitable. You know, we grabbed the sample, we flew it back to Earth, we're headed in for landing, but it's never that simple, is it?
No, not at all. And so we have...
Yeah, it has been a while since we had one of these live streams where something went terribly, unless I'm totally missing something.
Go from 27,000
There's been
miles
an
an hour
amazing
down to
level of
essentially
success
11
recently
for
on
that
these
safe landing.
types
All
of
these
missions.
things involve changes in environments, forces, things that could disrupt our sample and change them, which we want to document. And so we really want to understand this and finally bring it to rest so we can then bag it and encapsulate it so we can eventually get the sample into our clean room here. So we're ready to transfer it tomorrow to Houston to the Johnson Space Center. So this is a big process, well rehearsed by a masterful team.
Absolutely, and contains, you know, work from thousands.
That was very interesting there. So he did mention that this sample is going to be subjected to, you know, high levels of heat, huge accelerations, and they're going to map all of those to see if there's any changes that those could make to the samples, and hopefully those can be teased out later if necessary. So that was a very interesting little tidbit there.
To the clean room and get that sample, that sample canister inside the sample return capsule, get it under nitrogen purge, meaning we flow nitrogen gas so no Earth atmosphere and microbes get involved. That'll happen today, period of few hours, and then tomorrow we transfer to the Johnson Space Center in Houston, Texas, where all the fun happens at the Astromaterials Curational Facility, where we've done moon rocks.
So they're going to fire nitrogen in there, get that nitrogen over the samples, because nitrogen is an incredibly inert gas that doesn't really react with anything. So that will stop it interacting with things. So they put nitrogen into like bags of crisps to stop them going off for a long, long time, right? They put them into packaging, nitrogen into packaging, because it's an inert gas. So that will stop it interacting with elements in the Earth atmosphere. You don't want to let any oxygen in there, things like that, which can change the composition.
As the SRC approaches the edge of Earth's atmosphere, we are just moments away from the world's largest ever asteroid sample return. Jim, what are you feeling right now?
I am literally tingling all over with
Jim is loving life. He's loving it.
For a capsule and a giant leap for science.
It really is, and if that's one thing we can impart, that is it. This is a huge, huge milestone, a great achievement. So this is it. We are just 15 minutes away from the OSIRIS-REx sample return, a journey of 7 years and nearly 4 billion miles. The work of thousands culminates in this moment. Let's turn it over to our mission commentator, James Traley, to take us through the final moments. James, we're all yours.
Yeah, Lauren, buckle up and get ready for the ride of entry.
Last 15 minutes,
this is
folks.
13 minutes of crazy descent, punishing crazy deceleration of our spacecraft, starting at 27,000 miles per hour when it enters into Earth's atmosphere, and eventually slowing to a leisurely 11 miles per hour as it descends and lands on the Utah Test and Training Range.
Recovery operations. Helicopters 1 and 2 have arrived at the holding location.
So good news, our helicopters are ready to go and begin those recovery operations just as soon as we have confirmation of touchdown here. And as the sun begins to rise in the west coast, the SRC is going to be streaking across the atmosphere above San Francisco, California, about 82 miles in altitude. It's going to be coming in hot, over 5,000 degrees Fahrenheit, almost a couple seconds after it hits that atmosphere. That's about half as warm as the surface of the sun, to give you some context. But don't worry, our sample will be safe and sound within. We have a heat shield, which is made of a phenolic impregnated carbon ablator. It's a very fancy term to describe what's going on with this heat shield. It basically ablates away or burns away any kind of heat flux that develops on that outer shell, making sure that our sample is safe and cool within. Similar technology that we use with astronauts coming back from the moon or any kind of other landers that we have going into planets and moons. So we're just a couple moments away from this key moment. It's going to be very exciting.
So I guess astronauts don't get burnt up and reacted away. So these samples should be okay.
As they begin to get us ready for this key moment. It's a journey of 3.86 billion miles getting reduced to the scale.
That
of
heat,
mere
of course,
miles.
allows
82
very, very
miles
easy
above
tracking,
the surface of the Earth in
because
San
you can
Francisco.
get
A
in
couple key
IR
events are
right
gonna
across
happen as soon as
the
we get into the Earth's atmosphere.
right across the
Very
trajectory.
quickly, we're going to deploy our drogue parachute. This is for stability, stabilizes our descent, and make sure that we are continuing to target that landing ellipse that is here in the Utah Test and Training Range. It is a 36.5 by 8 mile landing ellipse that is here, marked out for that recovery operation. You see on your screen now the mission ops team.
So obviously helicopters ready to go, because we can't measure, we can't land it on a dime. It's going to be somewhere within that large Utah area, but you know, on a relative scale, hitting the bullseye.
Ready on the edge of their
But we
seats.
need a
This team
helicopter
aligned
to get out there
hours
quickly
ago
to get the
gave
damn
that
thing.
command to release the SRC on this long journey. It's been on its own for 4 hours. There's nothing we can do at this point. It's coming in, rain or shine.
EO milestone. The SRC has entered the Earth's atmosphere. UTTR tracking assets have acquired.
And here we go. Start your stopwatch right now. We are
So it's
13
entered the
minutes
atmosphere
into
and it's been
descent,
acquired.
We have that expected milestone of entering into the Earth's atmosphere. We can see the team at Lockheed, and we actually have a visual now. This is from our infrared
glowing in
camera on the
infrared
WB-57
because it's so hot,
high-altitude plane.
flying through the
At
atmosphere.
about 47,000 feet MSL, mean sea level, getting a great view of that SRC heating up as it enters into Earth's atmosphere. The punishing deceleration that space
Glowing just like
right now,
a meteor
as it comes
would.
in at about 27,650 miles an hour. You can see it glowing brightly in the sky. And in just a few moments, we're going to reach peak heating and peak deceleration. That's at 32 G-forces, punishing G-force on our SRC. A phenomenal view of that streaking SRC coming in across the sky.
Remember, this thing has just been flying through space with none of this air resistance. Suddenly hits the top of the atmosphere. Very, very severe deceleration.
Approaching the Utah Test and Training Range just a little bit further to the east. Entry was at
EO milestone. SRC is experiencing maximum heating and maximum deceleration.
So you just heard right there, we're experiencing that 5,000 degree Fahrenheit maximum heating, burning scalding hot on that heat shield that is protecting our sample within, and maximum deceleration that is at 32 G-force, punishing deceleration from Earth's atmosphere, the drag forces that are acting on that SRC.
Amazing.
Once again, as I mentioned, that sample is safe and sound within that SRC, that sample return capsule, as it comes in, burning through Earth's atmosphere. You can see our high-altitude plane searching for that SRC. You can see it faintly on your screen there. Our next milestone will be expecting that drogue parachute deployment. That'll be at about 102,300 feet altitude. And as I mentioned before, that will stabilize our descent and slow us from
streaming very quickly through the atmosphere. So we should be seeing a parachute very, very soon.
Expected EDO milestone. SRC commands drogue parachute deploy.
So we heard that command to deploy the drogue parachute. Waiting to see that visual confirmation, but that is at 102,000.
Hopefully the sensors haven't been burnt off, and we'll get that parachute deployment very quickly.
8:44 a.m. Mountain Time, the OSIRIS-REx spacecraft is at its closest approach to Earth. That will be on to its extended mission, visiting the asteroid Apophis in the year 2029, continuing this incredible mission at another world.
So another 6 years onto Apophis after this,
just a few moments, we should
after this
enter
drop off.
into special use airspace at approximately 8:46 a.m. That's going to be at 10 miles off the deck here at Utah Test and Training Range. You can still see that SRC on your screen very faintly in the distance. Still quite warm, that fireball that literally was a ball of plasma just a few moments ago when it first entered into the Earth's atmosphere.
So cooling down now.
SRC is nearly 3 feet
as it
wide,
slowed
1.6
down,
feet tall. It's a
less
small
air
object, so
resistance.
quite a challenge to track this as it comes searing into Earth's atmosphere.
So harder to see at the moment because it's not glowing so bright.
Airspace. This area was specifically chosen for this mission. It's a wide open, vast desert space, relatively flat, perfect to land this sample today.
So yeah, we want to keep good eyes on this because last thing we want to do is
as I mentioned,
for it to go missing in the Utah desert
days of
somewhere.
rain here, leading up to this event.
There
so
we
the
are.
ground is a little bit soft. You can see our SRC.
I want it to fall in some deep ravine somewhere.
Streaking in. This is from our high altitude cam.
So some high altitude planes getting live images here. And in comes the capsule.
Our next milestone, we should be expecting main parachute deployment at around 8:49 a.m. Mountain Time. That will be at around 5,000 feet elevation. We continue to track with our high altitude camera here.
So at 5,000 feet, we should have the parachute deployment and then just drift gently down to the surface.
As I mentioned, that sample is thermally isolated within that SRC, a very complex labyrinth network of piping and tubing leading into that sample canister within that just a few years ago was on the other side of the solar system from us sampling an asteroid Bennu.
Yeah, as we said, very, very, very important to keep it
The team has
isolated
incredible
completely.
precision on this mission as well. Just a few days ago, on the 17th of September, they did their final trajectory correction maneuver, TCM-12. This corrected our velocity by 3 millimeters per second.
Oh.
We see
Ah,
We have confirmed
parachute deployed.
wow, and after an exhilarating streak across Earth's atmosphere,
Amazing.
we have parachute deployment. You can see just a sigh of relief from the team. I can hear some applause here. There is that orange creamsicle color.
So remember,
parachute,
all
just a
of these
delight,
things
a
have been
sweet
in
delight to see
space for
in our
years
sky
at this
here over
point,
the Utah
and they
Testing Training
still have to work perfectly
Phenomenal view,
on
just
this descent.
Wonderful to see that
Amazing
deployment.
achievement.
That is at around 5,000 feet elevation above the Utah Testing Training Range, and now this is like a marathon runner savoring that last lap here as we approach the finish, that landing in the Utah Testing Training Range. Wonderful to see that. We continue to track. This is with our high altitude camera still, that WB-57. And we should have a great view from here on the ground. We've got a variety
Yeah,
of
I
different
was just
tracking
thinking
assets.
we
saw
should be able to
Sophia
see it from the
out
ground
at the edge
soon.
of that ellipse, watching from Wig Mountain. The team there could potentially have a wonderful view momentarily as well. We'll continue to descend. Our next altitude descent will be at about 4,000 feet. Just a few minutes away from getting that sample from the other side of the solar system, from the surface of asteroid Bennu at sample site Nightingale to the rugged terrain of the Utah Testing Training Range. It looks like winds are relatively low. Not a lot of rocking back and forth. Those parachutes seem to be perfectly smooth coming down, that parachute there. Continuing to descend, the slight little bit of tilt back and forth of our SRC as it comes to its resting velocity of 11 miles per hour as it makes that final descent. That parachute deployment was given internally by the spacecraft. All of what you're seeing now is autonomous on board that SRC.
Amazing. So all had to work autonomously. Not signals
Once
being
that's
given from the
successfully landed,
ground.
The teams will begin the next crucial phase of this mission, the sample recovery operations. They've been rehearsing for this moment for months, literally years really, leading up to this key moment, and are ready to begin those operations to get that SRC into our portable clean room here and extract that sample canister within.
Ah, Gio, I completely missed your comment. Currently living in the UK, grew up in Phoenix, Arizona. Southern border of Utah. Utah is very hot and dry. Makes sense. Makes sense for the choice for this recovery operation. Thank you for that, Gio. Thank you. Totally missed that. My fault.
This is a variable clock, so this could be a little bit faster, a little bit slower as we get closer in. This wind speed here is a variable that is quite hard to predict, especially once you're high up in the atmosphere. We did release a weather balloon earlier on this afternoon, or earlier on this morning rather, to get a profile of our atmospheric conditions. The team puts those into various models as they prepare for this key moment. But once again, they are a little bit hard to predict.
So less than 5 minutes and we should be on the ground.
Bounce around a little bit on that predicted OSIRIS-REx sample return capsule touchdown time. The ground really closing in now on that SRC.
EDL milestone. Hilo 1 has visual on the SRC below the chute.
That is phenomenal. Let's see that view here from that first helicopter. They've got visual on the sample return capsule under parachute, that orange creamsicle color parachute, really bright in the morning light over the Utah Test and Training Range.
So
great
good.
view
There's
of
a
the SRC
sample
we can
pod
have
on the
now
end
from
of the
helicopter
parachute. That's always a good
as it
thing.
continues to make its final descent to the terrain below. And once again, just setting the context for this, when we first hit the top of the atmosphere, we were at 27,650 miles per hour. We are now leisurely decelerating under our orange parachute to 11 miles per hour. Incredible amount of deceleration there, as Earth's atmosphere really helped us out quite a bit, getting that initial deceleration, our drogue parachute initially stabilizing our descent, and then ultimately that main parachute bringing us home. You can see right in the center of that crosshair, that is the parachute with the SRC dangling beneath.
So this now images
The
from
team on
the helicopter.
The team on the WB-57 doing a
DDL
great job.
milestone, we have touchdown. I repeat, DDL, SRC has touchdown.
And touchdown.
Touchdown apparently 3 minutes early.
Capsule. A journey of 1 billion miles to asteroid Bennu and back has come to an end, marking America's first sample return mission of its kind and opening a time capsule to our ancient solar system.
Amazing
Unofficial
stuff.
touchdown
So
time,
on the ground.
8:52 a.m. Mountain. And the team can now breathe an immense sigh of relief. We now have the sample return capsule, the SRC, containing pieces of the asteroid Bennu. You see the reaction there just moments ago as they got that sample back on the ground. This is the team at Lockheed celebrating that momentous achievement of getting that sample from the other side of the solar system at asteroid Bennu. When we took that sample, we were over 200 million miles away from us here on Earth. The long journey back, 1.2 billion miles from asteroid Bennu, back to here with that sample, has just come to a dramatic close. And a little bit ahead of schedule, too. The SRC landing about 3 minutes ahead of when we had originally predicted.
Not bad for
It was a
billions
rush
of
to get
miles
back to
traveled to be 3
carrying
minutes
the
out. We'll
amazing
we'll
amount of
allow that.
scientific information within. The team is eager to crack that SRC open, get the sample canister within, and begin the process of understanding the origins
Exactly.
of our solar
Whoop whoop,
system
AB,
and
definitely.
potentially the origins of life.
Amazing stuff. Let's hang around, see the sample being picked up, and then we'll wrap it up. If anyone has any
We're not in the clear just yet.
any comments, any questions, please please put them in the chat, and we can hash them out. But let's see the sample being picked up, or the sample
and will operate much like a
pod being
Formula One
picked
pit
up.
crew, if you will, to recover the SRC, take environmental samples at the landing zone, the LZ. Everyone has a role to play. It's going to be simultaneous action as they get that SRC recovered and begin to do an environmental safety sweep.
So that's another interesting thing. They're going to do an environmental sampling of the surrounding area of the landing, I guess, again. So you can, if there's any contamination in the sample, you can sort of try and tease that out or understand where that's come from. Again, trying to make sure that there's no contamination or any contamination, any change to that sample, we can at least
The
understand.
next phase of the operation is simply to get that SRC into the portable clean room that has been specifically set up for this recovery operation. The team will then remove the heat shield protecting the SRC and its precious cargo within the entire descent through the entry, descent, and landing, remove the back shell, and then extract the sample canister within the tag SAM that just a few years ago collected pieces from the asteroid Bennu. Today, the goal is to get the sample canister.
Recovery operations. Helicopters 3 and 4 are leaving rig for the landing ellipse.
You see some big smiles from the team there. They are getting those helicopters out to the landing ellipse now to begin those recovery operations. The first person to approach the SRC is Stu Wiley, our on-scene commander. You see the helicopter, the last of them, taking off from the Wig Mountain just at the edge of that landing ellipse. These helicopters will have a trip out to find that exact touchdown location of the SRC and begin those recovery operations. Stu Wiley, our on-scene commander, will be the first person to approach that SRC. He'll do an environmental safety sweep checking for unexploded ordnances. As he mentioned in his interview earlier with Sophia, he understands this range. He's worked here for a number of years. He will brief the team on any
Unexploded
dangers that
ordnances.
presented
Wow.
to them as they begin those recovery operations. And then the
So
team
not
from
only do you have to go
Lockheed
get the
will
sample, you've got to worry
gas
about
and
the
thermal release once
unexploded
the
bombs that are
various
hanging around.
of that
Okay.
SRC. to determine whether or not it is at safe operational levels for the rest of the team to begin the recovery operations. As I mentioned, this is going to be simultaneous action. The team has prepared. They're all going to be wearing these bright white UV shirts, sample recovery shirts, and you'll see them walking out to that sample in just a few moments here once those helicopters land. A great view once again from our high altitude plane. You can see the parachute there next to our SRC. There is a possibility that there could be unexploded ordnances from that parachute. There is a mortar inside that is to fire, to disconnect the parachute from the main SRC, to help it come to a final rest. It's a bit challenging to see from this perspective, but there could be some potential roll marks or skid marks as that SRC came to a rest on the rugged desert surface below. As I mentioned, we did have a bit of precipitation here the other day, so that should make for a nice soft surface for that SRC, so it probably had a nice clean landing there. The team will assess as they get out there and check exactly how our conditions are for the SRC and the surrounding area. You heard Stu mentioning the team might need to wear some boots. The operations could get a little bit slippery as they begin to recover that sample. And this is a pristine sample from the ancient solar system and could hold the clues to how everything around us came to be, from the formation of the planets to the origins of life here on Earth. Needless to say, this is precious cargo, and the recovery team is fully aware of the gravity of the situation and the importance of what they're about to do today with these recovery operations. You can see it looks like our parachute has come to a stable rest. The winds were pretty low today, so it looks
you can
like
see
it
the
is
parachute
not
here.
going at all. It is almost perfectly flat.
Red
at least
and
from this
white parachute.
perspective, on that desert terrain.
And hard to make out exactly what the capsule is,
Throughout all
but
these
maybe
operations, the crew member
one of
safety
these
is
bumps
paramount.
here.
So you'll see the team probably huddle up a couple times as they begin these recovery operations to make sure that everything is safe and continues to be nominal as they make their initial safety sweep. All of this recovery should be a very quick process usually. They've rehearsed for this again for months. They've been out here all summer really rehearsing for this moment. They did a drop test last month. They've also had numerous rehearsals actually practicing containing that SRC, getting it on a sample carrying fixture.
Recovery operations, WB has located the parachute on the ground.
And you just heard that confirmation from that high altitude plane locating that parachute on the ground. This location info will be relayed to our team members aboard those helicopters as they begin their approach out to the landing zone. We do have that confirmation from the high altitude plane, as you just heard. We're still working to get confirmation from our NASA helicopter. It is on its way out to that landing zone as we speak, so we should hopefully have that view up in just a few moments.
So we're still getting the images from the high altitude plane. The helicopters are on the way to pick up the sample, but they haven't got a visual of it on the ground yet, so we can't see that yet.
Is Rich Witherspoon from Lockheed Martin. He has been leading a lot of these operations for the past couple months. He's been preparing the team for this exact moment and really has been a great leader helping us get ready for these recovery operations.
Should hopefully get that very soon.
So this ellipse here, this landing zone, is a quite large setup here, and this was chosen intentionally for this mission. It's about 37 miles by 9 miles total, this landing ellipse, out in the Utah Test and Training Range here in Dugway, Utah. This is an enormous facility. As you heard earlier, it's about the size of Rhode Island, all in all, this whole facility. It's relatively flat, very smooth terrain, this desert surface. So it's perfect for bringing something back and having that nice, safe landing on the desert surface. Just a few years ago, the OSIRIS-REx spacecraft back in 2020 made its tag attempt, the touch and go attempt to actually collect the sample that has now landed in this desert. When it did that, it was only at the surface for just a couple seconds, descending at a speed about 11 centimeters per second, just a little bit faster than a baby that is crawling. It's a very slow pace, but they were able to successfully get that sample and bring it from the edge of our solar system back to us here at that Utah Test and Training Range. You can see our full screen view here of that high altitude view, looking at the parachute at rest on the surface of the desert. This is at the Utah Test and Training Range. It's a wide open expanse here. and the team has this positional info, and they'll be relaying that to our helicopter teams to begin those recovery operations.
So as we said, we got the images from the
And
high
you'll see in a
altitude
couple
plane
seconds
here.
The recovery team.
And the recovery team is moving in the
responsible
helicopters.
For securing the sample return capsule, the landing site around it, and helicoptering the SRC to a portable clean room that's located just next door here on the range. And just a little bit later on, it's going to be attached to a 100-foot long line beneath one of the helicopters, and then will actually be flown to the clean room. This was determined to be the best possible way to transport that SRC safely and efficiently, to get it on a nitrogen purge and maintain that pristine nature of the sample within. As I mentioned, this is
So the portable clean room's been set up. It's going to be put straight into there, and then that's going to be, the whole room's going to be helicoptered off to the main clean room.
Approach across this rugged terrain. With the helicopters, it will be approximately a 20-minute flight back with that SRC. They take it at a nice slow pace, effectively parading the SRC around, just giving it its last big moment as it is served its purpose officially at this point of getting that sample canister safely here to Earth. Once we actually land and begin those recovery operations, you'll see a lot of team members out beginning to take samples, both air and also soil samples from around the area. These are places of interest for the sample curation team that will actually open up the sample canister in the coming days down at the Johnson Space Center in Houston, Texas. They have a phenomenal sample curation facility there, and these samples from asteroid Bennu will join a historic collection of other asteroid materials, including samples from the Apollo mission, samples from both the Stardust and Genesis missions, as well as Antarctic meteorites that were collected by our scientists. In the coming days, we'll actually know exactly how much sample we got back from Bennu. The original mission requirement was 60 grams of pristine sample from the asteroid surface. Based on some very clever engineering, the team believes that they have potentially 250 grams, or 6 times that mission requirement, inside. And so we just heard that unofficial touchdown time was at 8:52 a.m. Mountain Time.
6 times 60 is not 250, but
Utah.
Very, very good.
Us, you see that view
Probably
right now
4 times as much as maybe they expected. 4 or 5 times as much.
On your screen, just above that crosshair, is the orange creamsicle colored parachute that brought us the last part of our journey down to the surface of the Earth. You heard from Jim earlier that that main parachute is about 24 feet across. Fairly large parachute that helped us decelerate on our last leg of the journey.
So I want to see this helicopter pick up, and then we will call it a day.
And so we just heard a confirmation, actually, that the main parachute deployed much higher than was originally anticipated. It was originally supposed to deploy at about 5,000 feet elevation, but it actually deployed at around 20,000 feet, so much higher up. So that would explain our kind of earlier touchdown time than expected here.
I would have thought that would have made it later,
Still
but
has touchdown on the
there
Utah
we
Test and
go.
Training Range. Team members continue to fly out to this location aboard helicopters. As I mentioned, there are 4 recovery helicopters in total. The mission operations team is continuing to monitor the situation. They're the ones who are relaying us that info about that high parachute deployment, that 20,000 foot parachute deployment. They're going to be assessing the situation from their end here, relaying any possible info over to our recovery teams as they begin to make their trip out to our SRC. One of the first goals once the team gets out there is to safe and stow the parachute. and begin to mark places of interest, as I mentioned, for that curation team to begin sampling. This is all a very well-coordinated machine, very well-oiled machine that operates in tandem. They've rehearsed extensively for this moment. So we just heard from the team in that mission operations room that they have visual of the parachute, that orange parachute that you saw on your screen moments ago. But we do not yet have visual confirmation of the SRC itself. The team is continuing to survey the region, looking for that sample return capsule.
So we'll give it 5 more minutes because they seem to be taking their sweet time looking for this, using these helicopters to find the capsule on the surface. And I have to run off shortly. But let's give it another 5 minutes and see if these helicopters can locate the sample on the ground. If you have any...
Recovery operations, Kilos 1 and 2 are in the area of the landing site and are in a search operation.
So you just heard that call out from Tim Preiser, who you see on your screen there from the mission operations room. He just announced that Helos 1 and 2 are now at that landing site. They're pointing out something on the screen. I see some smiles. It seems like we might have potentially some more information on that SRC in the coming moments.
So if you have any final comments, questions,
will be surveying this region.
Stick them in the chat. Don't forget to drop a like if you've enjoyed joining us today.
That was deployed.
Recovery operations, all of the ground supported vehicles have left rig and are in pursuit of the landing zone.
So some more team members are going to be heading out to that landing zone as well in support of those 4 helicopters that will be the main group recovering that sample. The main helicopter will be actually attaching that sample return capsule once the team has it located and ready to prepare for recovery operations. They'll load that on long line. You can see some, once again, some team members pointing at items on the screen here. We'll hopefully get confirmation in the coming minutes of that SRC location. Tim Preiser pointing at the screen now, wondering if he has any more information for us on where that sample return capsule location would be. We do have visual confirmation of that parachute, as I mentioned. Rich Witherspoon radioing out to the team, and now we have a view from our helicopter.
There we are. Good, finally.
Of the landing location, you can see.
View from the helicopter.
The sample return capsule, dead center on your screen, that kind of dark gray black object right there.
Here.
And then just to the right of it, a little bit below, is our parachute. It appears to be resting on the surface. We're getting a zoom in now from our NASA helicopter.
That might just be a boulder, is it?
And you can see now the
sample
SRC.
return?
At last, we have a visual of it on the surface of the Utah Test and Training Range.
Here we are.
I'm sure that is a pleasant sight for the team to see.
Amazing.
Kilo 2 has visual on the SRC.
Landed right next to the road, apparently, by the look of this. So,
and we have
very nice place.
SRC. It appears that the parachute has also disconnected. It's a little bit off from that SRC, disconnecting from the back shell. The SRC appears to be resting on its nose, that heat shield.
Oh, yeah, it is this one. I thought it might be a boulder, but it is this
one. And landing.
Very nice position to land. People can come by with the car.
Breathing another sigh of relief here. It's been a wild morning for everyone involved. They've been up since the crack.
Hope nobody was driving past at the time.
Waterton, Colorado. They gave the go command to actually release that SRC that you see on your screen right there from the OSIRIS-REx spacecraft about 4 hours ago. It then ventured entirely on its own and now sits on its own for us here in the Utah Test and Training Range. So now that we have visual, the teams should be able to begin the recovery operations in just a few moments. As I mentioned, that first person on scene will be the on-scene commander, Stu Wiley. He'll be doing an environmental sweep. We're getting a nice close-up view. You can see the parachute disconnected. You can see some of the wiring of it.
I'm glad we hung around for this this final view here.
The SRC looks quite charred up from that entry in. That was expected, as we heated up to temperatures over 5,000 degrees Fahrenheit upon entry into Earth's atmosphere.
So the helicopter's circling around to land.
Out there. Just a sweeping expanse, very panoramic terrain at the Utah Test and Training Range. It's a great location for us to land this sample. The team looking a lot more relieved now that we actually have visual. and we should be able to begin those recovery operations shortly. Inside that sample return capsule are pieces of the asteroid Bennu. We'll be getting access to those samples in just a few days and actually seeing exactly what we got from the asteroid regolith. This mission continues to amaze me and everyone involved here. The engineering is ingenious for this mission, getting us with a robotic explorer to the edge of the solar system, collecting that sample, safely stowing it, and then actually transporting it back here to Earth for us to open up and analyze.
Yeah, truly amazing stuff.
The surface today was probably a little bit soft, so it looks like it's resting a little bit far off the actual desert. It doesn't appear to have dug in too much with that nose cone from the heat shield. You are here with us as we witness this historic moment. It's the first time the United States has delivered samples from an asteroid to Earth, and these samples will be analyzed for decades to come in laboratories around the world.
There we go, helicopter landing on the ground.
And there is landing of our first helicopter at the site. Appears to have a nice soft landing. We're just probably a couple hundred feet.
Recovery operations. Helo 1 has landed at the recovery site.
So our first helicopter, you just heard confirmation, and you can see visual confirmation of that landing. We're maybe about 100, 200 feet away, landing away from that sample. So a little bit of a hike for our team members to get out to that sample return capsule and begin our environmental safety sweep. As I mentioned, our on-scene commander, Stu Wiley, will be the first person of the team to actually approach this sample, check the area for any unexploded ordnances, UXOs, that could possibly be out there on the range, and then also make sure that that SRC is safe for our operations team to approach and begin recovery. You can see where that parachute disconnected from the top of that SRC. That is the back shield that you see right there at the very top with that little bit of white wiring still coming out of the top. Our SRC perfectly landed there on the Utah Test and Training Range.
Amazing stuff. So I think we're probably going to call it a day there. The sample return capsule is on the ground. People are moving in to recover it. So we have these pristine samples from an asteroid back on Earth. 250 grams, about 9 ounces, a baseball and a half. And hopefully from those samples, we're going to be able to find out a lot more about how the solar system came to be and maybe even how life came to be. And I'll keep up with all of the analysis of those samples over the next few days. So stay with the channel. Please remember to drop a like if you enjoyed being with us today. And please check in the next few days for more. So thank you very much for being here today. And I will catch you again soon. Take care.